hold it still. Okay, you guys, I'm going to do number 8 here, where we have ammonia chloride reacts with calcium hydroxide to form calcium chloride, ammonia, and water. Okay, so we have the NH4Cl, which is, of course, a solid. It reacts with, so that means that we add it to the calcium hydroxide. Now the reason I knew there was a 2 right there is because calcium has a 2+ charge and hydroxide has a 1- charge, and you crisscross to figure that one out. Okay, so it forms. To form means you draw an arrow. So we're going to put the arrow there, and it forms calcium chloride. Once again, calcium has a +2 charge because it's donating 2 electrons. So we're going to put the subscript on the chloride, and ammonia plus NH3. They give you that chemical right there. And of course, dihydrogen monoxide, water. Okay, now what type of a reaction is this? Let's see. Let's go ahead and balance this first. The type of reaction is a little bit odd to me because it seems like a double replacement. However, we have 3 products, so it is a little bizarre for this one. We'll address that when I get back to the classroom. Now, how do we balance this? We have 1 nitrogen, 4 hydrogen, and 1 chlorine. So let's focus on the nitrogen first. So we go over to the nitrogen. We have 1 nitrogen here. We're good with the nitrogen. We have 4 hydrogens, and then 2 more with the calcium hydroxide, giving us 6 hydrogen in the reactants. Then we come over to the product, and we have 3 hydrogen and 2 hydrogen here. Well, we already know that we're going to have to put a 2 in front of the water because we need 2 oxygens, and to make up for our 2 oxygens here. So that in turn has given us 2 oxygens, which makes up for our oxygens. But now we are up on the hydrogen. Sorry for the brief pause, folks. We had to move inside. But to finish balancing this particular reaction, we are going to actually have to go back to the ammonium chloride and place a 2 in front of it, giving us 2 moles of ammonium chloride, because our hydrogens would not have balanced out otherwise. Therefore, now we have 2 times the 4, which gives us 8 hydrogens here, and then these 2 hydrogens, which gives us 10 hydrogens in the reactant. But we need to make up for that in the product by giving us a 2 moles of ammonia, which, as you can see here, now we have 2 times the 3, which gives us 6 hydrogens here, 2 times this 2, 4 more, giving us a grand total of 10 hydrogens. Our nitrogen are still balanced, our calcium is balanced. We are good to go. I'll get back to you on the type of a reaction it is.